Hello everyone, welcome to another day of daily programming with Sig. Today we're going to be hopefully finishing up our Tetris clone we've been working on the past few days. Today's the day. Yes, I am excited, I hope you guys are. Yesterday we made a lot of the core functions needed to make this game actually work. So today we're going to finally see and reap the fruits of our labor, hopefully. The very first thing I'm going to do is establish a J-frame, and a J-frame is required in order to display stuff on the screen. A J-frame is just a program window. It's going to hold components, specifically Java Swing components. We're going to be using Java Swing for this. Java Swing is built in, and it's very easy to use. So, the first thing we want to do is actually create the window. Creating the window is very simple. All you really have to do, frame? We're going to first, do this. This sets the default close operation, and there are a couple of different things you can do. The easiest thing to do is, exit on close, which will close the window when, yeah, it will close the window, which is what we want. So it looks like it's window constants and exit on close. So by adding this, we're saying when we click the exit button, it'll actually close the window and we won't have to manually make it disappear. We need to set a size. The reason we have to set a size is so the window is not some tiny little thing. In my case, I think an 800 by, let's see, let's do a 16 by 9 aspect ratio actually, because most monitors are like that, right? Let's do like 30. 1024? 1024 sounds good. So 16, so we do 9 times 64 as well, 576. So this is a 16 by 9 aspect ratio. I don't want it to be too big, I just don't want it to be smaller than like 800 by 600, which is a 4:3 ratio, which is kind of old school. I mean, I guess Tetris is an old school thing, but you know. The final thing you have to do is set the window visible. And by doing that, it's going to create an actual window. So if we were just to run our program now, you'll see, well, this appears. Actually, I think we have a null pointer. Hold on, let me figure out why the frame didn't get created. I think we have a null pointer, that's why. Frame equals new J-frame. How about that? There we go. So this is our window. 1024 by 576. Nothing inside of it yet. And no title. Let's give it a title. My Tetris game. So that when you start the game, it shows my Tetris game. And if you hit the exit, it does close the window as expected. So this is how we create a basic window. Now we have to actually get stuff in the window. So the best way to do graphics with a Java Swing is to create this thing called a canvas. So we're going to be creating a custom canvas. I'm just going to call it the game canvas. This class doesn't exist yet, it's not a default thing. We're going to be adding it and extending what's called a, I want to say it's a I forget what the name of it is. We can take a look at one of my other apps that utilizes it real quick and see what it's called. I think it's like almost like a window. It's kind of the same concept. Let me see if I can pull something up for you guys real quick. It's a J panel. So a J panel can draw graphics. It has the capability to override the paint component method. So that's what we're going to do. We're going to be making a game canvas which overrides a J panel that we're going to be adding to here. So we'll just call it a canvas for now. So we have to create the class, and it's going to be extending a J panel. Now after you add this in, you're going to have to implement stuff related to the game canvas. One of the things we try to do is override the paint method because we're going to be changing what we do when we repaint. So for example, like in this game canvas I use here, you can see I override this paint component method, and this is your ticket into creating your own custom like canvas. You can see on my IDE it says it now overrides paint component, which is what we want. So what we do in here now is actually draw stuff to the screen. So what we can do is we can clear the screen. So it says clears the specified rectangle by filling it with the background color of the current drawing surface. So in this case we can do our width and our height, right? Now we kind of don't want to hard code it if we can avoid it. So we're just gonna make two variables here. Window width, I forget what it's called. 1024 by 576. Window width and window height. These are integers, by the way. They're also final, so they're not going to change ever. That way we can substitute that in here. So every time we redraw, we're going to clear the screen, right? That way we have a fresh slate to start with. Generally, in games, you refresh. We're going to be doing 60 frames per second. So when we repaint, it's going to call paint component. So just to show what this is going to look like structurally, in here we have to define our canvas. So we're going to do new game canvas, like so. And then we have to add it to our frame. So all we have to do is do frame.add, and then the name of the component we're adding. So now the canvas is included inside of the frame. It's just going to be included straight in there, depending on how you set up the GUI layout. Determines where this canvas goes exactly, but this canvas is just going to be drawn right there. So this is a custom canvas component we're drawing. I think the clear color is white by default, but I could be wrong. But if we just run it, it's going to draw one frame of it. Now you might notice we could resize the window, but when we do that, you can see that the repaint is called whenever you resize a window like this, so that's kind of nice. But you see the boundary is here if we resize like too far. For the case of our game, we're gonna remove the ability to make it resizable. So set resizable to false makes it so we can't resize the window. And so we're stuck with this window here. Now we have to actually do something with this window, right? Typically we want to draw stuff on it, but if we just draw stuff on it, then it's not going to refresh. For example, we want to draw related to our game state. I can do this in a couple ways, but the easiest way is to just get every block drawn to a certain coordinate on the screen. So here, right now, this is the current way to draw a block on the screen for the player's current block. So let's see, we have 1024 pixels to work with, right? We've got a grid that, well, our height is smaller, 576, so we have to fit 20 squares on at least 576. That means each block will need to be like 28 pixels in height max. So I'd say our block height should be our block size should be 24 by 24. That would be a good size to use for all of our blocks. 24 by 24 to draw our entire field. That sounds good, right? Now, if it's 24 by 24, let's specify some new things, variables here. Field width and field height. Field width and field height are actually related to what the block size is multiplied by 10 in our case, because the width is 10 blocks wide, the field is, and the height is 20 blocks high, right? And then we need a block size variable. The reason why I include all these in different variables is so when we write our code, we're not writing all these random numbers that we start to lose the meaning of, right? We want to keep our code as meaningful to us as possible, readable. So by using these variables here, these constants as we call them, we immediately know what these mean compared to these random numbers. If we see the number 240 or the number 480, we're like, what does that mean again, right? very easy to get yourself confused if you don't have variable names associated to your numbers. So here our block size is going to be 24 by 24, and we can calculate the width and the height based on those block sizes. Then using the width and the height, we can calculate where the field needs to be drawn. We want the field to be centered in the window. So field start x will actually be equal to the field, the window width divided by 2 minus the field width divided by 2. And if you want to just wrap your head around what the math behind this is, if the window is 1,000 pixels wide, then we have to divide by 2 to point to the middle, right? Because 500 is the center of that window. Then depending on how large our field is, if our field is 400 pixels wide, we have to start 200 pixels to the left, because then it'll be 400 pixels across, so it'll go from 200 to the left of 500 to 200 to the right of 500. That centers our field. So that's the math behind finding where the start x and start y coordinates are, and we do the same for the height. And now, when we're drawing our field, we know exactly where the field is going to be drawn from. So that makes it easy for us to quickly figure that out. So we're going to be removing all of our print line or print functions now related to drawing the game inside of a console, because we don't want to do that anymore. And instead of commenting out all these, I'm actually going to keep the function like this and just remove the... So this is all draw console board. We're going to refactor this to say draw console board, because that's really what it's doing. So we're going to comment that out and actually make our draw board function now. Now note, the draw board function actually needs to be called in here. And you'll notice there's a graphics item. This graphics variable is what we reference like all of our different draw calls with. It's like it's a graphics manager, if you will. And you can see it has a lot of drawing utilities. It can draw rectangles, images, polygons. I believe it can draw ovals or circles and lines. And strings. It's got all the necessary functions needed to draw to a screen, at least in a higher level perspective. You can also set the drawing color. So for example, I said I think the default drawing color was white. Well, if we go here, we can change the drawing color. Now it's referencing my sig.game.color, so I forgot we do that here. We're going to be referencing a different color here. So if we do java awt.color from that package, then boom. I believe this will make a blinding red background now. Oh, nope, it does not. That's a little surprising. But that's probably because we haven't repainted the screen yet. Basically, we called the field once, but we haven't repainted it. At least I don't believe we have. So let's get our draw board to first repaint. So in order to call repaint, you just have to specify repaint. And because draw board is inside of our step function, it will repaint once every frame. So let's see, there's a null pointer exception, as in the canvas is null. Probably because step is called before that. You can see step is called before, yeah. So we can fix this in one of two ways. We make sure we initialize it before we create our timer task. That's one way to do it. The other way is to actually check for null, but that's kind of annoying, right? It's still not redrawing in the right window color. That might be because clear rectangle doesn't clear with a certain color. Filling with the background color of the current drawing surface. Let me see if there's a background color. I don't think there is. I know if we draw like a rectangle on the screen, 0, 0, rectangle or coordinates start at 0, 0 being the upper left corner, and then going to the right and down for the x and y coordinates. So you can see it did draw a rectangle here, starting at coordinates 0, 0, 64 by 64, and that's our core way to draw items on the screen. However, I'm curious why it didn't this doesn't set the drawing color. I'm gonna see if I do the same thing in my old draw canvas or not, if I clear the screen. I'm gonna imagine I don't, and I just do a fill rectangle. It looks like that's the case. Beginning with Java 1.1, the background color of off-screen images may be system dependent. Applications should use set color followed by fill rectangle. Fair enough. It sounds like they changed their ways. Oh god, yes, it is a blinding red rectangle now. So that's how we clear the screen in a different color. But for our sake, we're gonna clear it into this nice little dark gray color. I like to go dark gray because it gives us like a sort of dark theme we can build around, making this easy for us. So we already know where we're gonna draw our field. We've already specified all the coordinates. So let's draw our thing. Here's how we're gonna do it. You can see canvas.repaint is just gonna call repaint every time. So you'll actually be building all of your stuff inside of here, and canvas.repaint is just going to call whatever needs to be drawn on the screen. So all of your logic goes into here. Now this is where you have to be careful. Do not, and I repeat, do not ever do any game logic inside of this paint component. Do all of your game logic inside your step loop or your tick loop, but draw board is only for drawing. You can only call functions that do stuff like this. If you put game logic in here, your game is gonna crawl to a halt. Remember that you want your game to be running at 60 frames a second. If you do any logic inside the loop that needs to draw to the screen, you are going to you're going to make it seem like your game is immensely slow. The draw functions are not slow, mind you, but what can be slow are all your implementations. Keep your implementations in separate places. The Java Swing library is threaded, or excuse me, not threaded, it's task oriented. Every time like a draw call needs to be made, it sends a task to the, it's kind of hard, it's kind of like complicated. There's a whole like a system behind it, but in short, it's like a queue. Things go in queue for processing, and then Java Swing pulls from its list of tasks whatever's next and then does it, and it keeps calling in this constant loop of checking for Java like swing events. So you need to keep your queue clean by not lagging down your paint components. Your paint components should be as fast as they possibly can be. And I've made this mistake in the past, which is why I'm emphasizing it so much. This is where you can slow down your program immensely if you're not careful. Anyways, the first thing we're going to do is write a loop to go through all of our, we're basically going to write this loop here. We're going to be mirroring it, because this is essentially how we determine all the blocks we have to draw, right? So we're actually going to copy paste this and just change a few things. Ideally, we can make this into a function if we really wanted to, but since we're not really, this is kind of an obsolete function, we're probably going to rewrite it and implement it inside paint component just to make things better for us. So we will need all of our player blocks. We don't know what P is, we're going to have to reference that from game. Again, that's why we made something static, because some things need to be referenced inside this draw loop. Like getting where our blocks are in the game, along with drawing our board. So we're drawing each block here. So this is where the player's blocks go. Now we have access to color. So the first thing I'm actually going to do is set the color, because we can draw our specific block with that color, right? So you might notice that we're currently getting points, when really we need to get more than points. We need to get the actual block. So it's kind of annoying that I made this return a point instead of a block. So the question is, do we refactor it? Because guess what a shape provides? I believe our shape provides a color, because it's a block. Well, it's got a block array inside of it. and a block can have a color. So each of these blocks does have a color value associated with it, and that's what we have to try to draw, except we don't have that structure right now. Right now we're returning a shape object without a color. So the first thing I'm going to do is make the shape object return a color, but every shape needs to use the same color because, well, it's the same block. So we're gonna add a color property here and make the color equal to whatever the first element's color is. That's like the easiest way to do this. Shape array 0, 0, color. That's the best way to do it, I think. That way each shape now has a color. And thus, we now have to pass in not a shape, but all of the points related to that shape. We have to go like a level into this function in order to get this. So right now we're returning a point array and a shape. We can return this as like a player blocks object if we really want to, with these values inside of it. It's just a matter of how exactly we want to refactor it, because we do need to get that color value out. And the way we factored it now, well, we're not going to get that with a point array. So we're going to be making a, I guess it's more like a helper class, in a sense. We're going to call this the player block class. The player block class contains a list of points that are associated with the player block locations, along with the shape itself, the related shape. And these two will be used to help refactor into this. So now we have to make our constructor basically equal to this setup here. So our constructor will accept a point array, points, and it will also accept a shape. Grant the import point, and we'll be moving these two, well, we'll be doing this dot points equals block locations, and this dot shape equals shape. Now, as for the, block locations equals points is what we want. And then you'll notice we're supposed to return a point array. So we'll still make this function called get player blocks in grid, but we'll do the calculation for it inside of here. So get player blocks in grid. And we already have the shape, so we know we're good there, right? Actually, the points array is built off of a shape. And if a shape has a color, then really we just have to return that color at that point. In fact, if we know the shape, then we don't even need to worry about that. Yeah. I just realized we can grab the color from here. My bad. I thought we didn't have the color at all. So this class can actually die. We don't need this class anymore. I just realized we can grab the color from here. That's good. That's all we need. So the color can be grabbed from whatever the current shape is, since we made it visible. I kind of missed that little detail there. Now you'll notice the color is not associated with an actual color, so we need to fix that, because color, as you notice, is not from that class. I'm going to make the enum color now associated with an actual color value from Java AWT or Java Swing. So what we'll do is java.awt.color, and you specify a new color with values 0 through 255. So in the case of blue, we can do blue. There actually might be constants for this, so I might just do something like that. Color.blue cannot be resolved to a type. That's kind of interesting, because you can see here that it is indeed an object that we can grab. So that's kind of interesting. Oh wait, it's a method. Oops. Okay. my bad. I just had like 10 million typos there for no reason. But yeah, we'll associate each one of these with an actual color. This one, I don't know why they don't actually show. Oh, probably because I need the constructor, huh? Okay. Let's have a look. I don't know why it doesn't pop up the colors in here. That's kind of weird. You can see if I go here, it does. But aqua is not a color. So what can we do instead? We'll have to make an aqua. So there's a constructor for color. And the constructor, again, is a set of values. So we'll do like 196, 196, 255. I think that'll get us pretty close to an aqua color. Not 100% sure on that, but we'll see. Purple. I believe all the other standard colors exist. We might have to use magenta there, but it's practically the same color. So now we have a color associated with that. We should be able to do, let's call it get color. And we'll return the color value associated with whatever enum we're returning. Is this not a... Oops. Yeah, we want to return the color. So if I now do dot get color here, we'll be able to get the color. So that's the first thing we have to do. Then we have to actually draw the rectangle at a certain position. So what we can do is we can make a helper function that translates a certain coordinate into an actual block coordinate. So we'll make a little helper function. Let's return a set of points because we need both coordinates. Get block coordinate to pixel coordinates. You'll probably make functions like this a lot. They're super helpful, by the way. Screen or block location. And all you have to do is return a new point with those translated. Now the way we translate it is we start at field start x and we add the block size multiplied by the block location dot x. And we do the same for the y. So field start y plus block size plus multiplied by block location dot y. And that way when we do our coordinate drawing, we don't have to worry too much about where to draw it because it'll be based on that coordinate. So we'll have the coordinates and then we have to place it somewhere. Block coordinate. We might actually use this in a couple places, so let's just do it like this. Block coordinate. Well, only when it matches. Yeah, I guess we'll do it locally here. Get block coordinate to pixel coordinate. And we'll specify a new point with... Actually, we have point already. It's stored as a point. That's kind of a nice bonus for us using points. So I'm going to do draw 3D rectangle. Draw 3D rectangle just has a little indentation in it. So it just looks kind of cool. We're going to make it sunk into the surface, so we'll be making the last value false, as you can kind of see by the parameters here. It has some interesting little perks there. So we'll be drawing at block coordinate dot x and block coordinate dot y. The width and height are determined by block size. So you can see we're using no numbers here, and that way it makes it easy for us to visualize what's going on. We don't have to write all these numbers and multiplications and stuff. That's all done behind the scenes through these kind of codes and constants. And that really helps you as a developer, because then you don't have any complicated things going on. We have to do the same thing, but down here. Now to draw these blocks, we have GameGrid.grid, which is going to have a block inside of it. So to get its color, we just have to do grid. Oh, GameGrid is not defined either. We're going to have to do game.GameGrid.grid, X, Y, and we should be able to grab the color from that block to set the color appropriately. We do .getColor to convert it to a Java Swing color. And then we have getBlockCoordinate to pixel coordinate, where we specify a new point containing X and Y. And then finally we draw that where we need to. And we don't have to include this anymore. So we basically just refactored our drawing console code into an actual Java Swing version of drawing the game board. So you can see here there's actually a grid of blocks set up here. I actually wanted to draw filled rectangles, so let's try a draw 3D fill. I think it's fill. You have to do .fill 3D rectangle. Yeah, that draws filled things for us. So you can see it's not updating, which may be a problem. Let's see. We call canvas.repaint inside of draw board, which should be fine, one would imagine. That's usually how we get things to redraw here. We can prove it's being redrawn. Because this should be getting, oops. Well, we can see errors repeatedly because I forgot a semicolon. So we kind of know it's being redrawn constantly. Perhaps it's because of the drawing order. The way I can think about it is we're drawing all the black blocks before the player blocks. But however, you might notice we have some logic here that says, okay, has this block been plotted? If it has, don't draw the black block because we don't need to. So these should be drawn at the correct coordinates then, one would think. Unless that color is not working. I'm pretty sure we specify our color when we grab a certain like shape. Because when I made the shapes, I did give them all a color inside of a frame. And the frame should be setting their colors. Okay, so the frame gets its color that way. Now what about the shapes? I'm assuming the shapes don't get its color. So maybe that's the problem. Because we make all these new shapes, right? So maybe we should set them right here. S1.shape or not shape. Color equals color. And we can do the same multiple times. You can just chain multiple equals together. It'll be evaluated from right to left. So it'll set color equal to S4.color, then, or S4.color to color. Then I'll do S3.color equals what is now color for S4.color. So color, 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 color. They'll all get color. Gets evaluated from right to left. Okay, there we go. You can see it's actually upside down though. That's kind of funny. And the reason why that happened is because if you recall on the console, you have to draw from top to bottom, not bottom to top. So we have to do an inversion on which way we order this. So we're going to be changing it from y equals 19 to y starts at 0 and going up to y is less than 20. So by doing that, we basically, or we should be flipping our board. I need to increment instead of decrement y. And it's still being drawn upside down because now I have to invert the y coordinate in relation to what the y is here. Color, color, color. Yeah, set all the colors. Also, hello, Smams, welcome. So basically, where we get our coordinates, let me see. start from 0 and we draw downwards now. I guess that means when we draw our pixel coordinates, they need to be inverted because the block Y location decreases. Like we start at the top of the field and we go down. And I made it so... yeah, the top of the field is actually considered location 20, while the bottom is considered location 0. So like we have our game logic kind of flipped, interestingly enough. So we have to actually do a minus on the field star y minus block size times block location y, which instead puts our field start y at window height divided by 2 plus field height divided by 2. So we're starting like from the bottom or the top instead of the bottom. So you can see now we have a visual drawing of our game engine. It looks like when the pieces snap to the grid, they don't actually lock in their colors, so I'm gonna have to fix that as well. We just didn't save that. Or we can play hard mode Tetris, where all pieces go invisible and you can't see the board. That's always fun too, right? Are you reconstructing? Yes, today is the final day of our Tetris, like, I guess, reconstruction. So yeah, we built all the Tetris functionality first in the back. So today's finally like just the fun stuff, the graphical user interface stuff. But all the game logic is all done, which is great. So in order to save the colors to the grid, we just have to make it when our piece snaps. Right here, this is where our snap piece that collided happens. We're setting all of our active grid spaces to active. The only thing we have to do is add a color to that space now, because we kind of didn't do that before since we had no color, so we didn't care about setting the color there. Just a minor point we have to do. So we make the color equal to whatever the current piece of the player is, and we just use that color to determine what the snap color actually is. So now we can see when the piece snaps to the grid, it actually keeps its colors there. So that's working as expected now. So the next thing to do is to make it into an actual game. And what I mean by that is allowing the player to control what's happening, not just having our code run on its own. So we're going to be making that next. So, to do player input in Java Swing, on any Java Swing component, you can implement what's called a key listener, or there are many types of listeners, but we'll be specifically implementing what's called a key listener, which allows us to listen for keyboard events. Whenever you implement an interface, you're given a set of methods to implement, so we're going to be, my ID automatically requests that we add unimplemented methods, so we will do so. The methods you have to override are key typed, key pressed, and key released. Each of these kind of does as they say. Key pressed will happen the first time a user like pushes down on a key. Key released will happen whenever the key is depressed, and key typed is whenever the key is being held down. So in general, we just use key pressed because once you press down a key, if you hold it down, it generates more press events like this, right? So you hold down a key, and that generates more press events. That's like the most natural way to do things, and especially in a game like Tetris where you want to like hold down a key and then it will keep scrolling like to the right or something, or to the left. This is an ideal key behavior, especially for a game like Tetris. So for Tetris, we're only going to be focusing on the key press event. The other two we don't really have to worry about. We have to leave them there because they are required for implementation, but we're not going to do anything inside of them. So inside of the key press event, you get access to this key event where you can grab a couple of things about the key. So in this case, we can grab like the key character or the key code. Now to know which key code yet to grab, there are these key event constants. So instead of memorizing what number associates to what key code, you can just use this giant key event enum, as it is, to associate with a certain thing. So every time we type key event dot whatever, we can get, like, say, VK right to represent the right arrow key, or VK left to represent the left arrow key. You can get a number, you can get a letter, it's all there. So we have all the keys we need by using this key press event here. So if I were to just say, let's actually use a switch statement for this, because a switch statement allows us to create a multi-logic check. So we're going to grab by key code here, and depending on which key code we get, we're going to do something specific. In this case, let's look at key event .vk left. We know we're going to be dealing with the left and right arrow keys. And let's also add in WASD is used a lot in games, so we'll add in the A key along with the left key for one particular control. So this is for left control. And we'll do another set for the right control. So right and D will be for what we're going to do when we press right. We'll also need a key that's going to allow us to change the piece rotation. You lost me at Tetris. Nice. So I think a natural key layout for doing this, at least on my keyboard, for rotating the key, we can do it with either left shift or spacebar, and or left control or numpad 0. Both are decent like control inputs, or Z or X. Like, all of these are valid like ways to control what is happening, because if you're using WASD, you're probably going to want something towards the right side of the keyboard, like maybe the comma, the dot, a slash. But if you're playing with arrow keys, then you'll be directionally controlling with the right hand, so you need something on the left hand, which could be like Z or X. Those are pretty common. So we're going to make multiple keys that represent the same functions. So Z, X, let's say comma and dot. Those are all good. Now comma and dot don't exist. I don't actually know the exact, I guess it's comma and period or something. Okay. So those constants will be used for rotation. Specifically, Z will be used for counterclockwise rotation, Z and comma, and X and period will be used for clockwise rotation. So again, we have to separate those. And then we also need fast dropping. So for fast dropping, that's going to be your down key, which is going to be either S or down arrow. Like this. So we specified our key layouts here for how we're going to handle our game logic. Now we have to actually incorporate the game logic. Luckily, all of our game logic has already been implemented, so we just have to tie those to our current events. So we're going to do game, and we'll have to do P, dot, and then we have rotate clockwise or rotate counterclockwise, and we have move block left and move block right. So these are all functions we already created, and now we just have to plug them in. And this is the power of doing all the game engine or logic programming that we did over the past 2 days, because now we just substitute all the logic we built into our final product, which is the graphical user interface. So Z is for rotating counterclockwise, X is for rotating clockwise, and then hard dropping. That's actually not something we really incorporated, and the reason is hard dropping just speeds up the timer. So if we recall from the last time we worked on this, we made a delay that determines how fast a piece will fall. So if we start pressing on this hard drop key, what we should do is tell the game, hey, I don't want to wait for this piece for the timer to go down before moving the block down. Just move it down. So the easiest way to force that is by setting the tick delay. In this case, our rotate timer value is going to be obsolete because we're going to be controlling it now. We mostly use this to test our functionality. We had the game automatically rotate the block every so often, which is what we saw earlier, or move the block. We were testing move block left at the time, but earlier we tested rotate. So this tick delay is how we control whether or not the game should drop the block quickly. So we're just going to say tick delay will be automatically set to 2. And why 2? Well, it's going to be decreased by 1 with every frame. So if it's set to 1 every frame, then it's going to be decreased each time. Actually, wait. 1 to 0, excuse me, because we're checking less or equal to 0. So set the tick delay to 1, so on the next frame, it's just going to drop the block. And so this should be all the functionality we need to actually control the game now. So, and the final thing we have to do is actually add the key listener. So I just tried to control it right there and I couldn't. And that's because we aren't actually listening for the events yet. So the final thing we have to do is inside our game frame, we have to add a key listener. So the key listener comes from the canvas object, which is extending a key listener. So naturally the canvas object is dispatching key events. So by including that, now we can control our game using the arrow keys here. I can hold down to drop quicker. I can use Z or X to rotate the pieces, and I can place them down like so. So this is the final piece of the puzzle we needed in order to create our functioning Tetris game. So you can see here our clear line didn't do what it was supposed to do, so it didn't refresh the screen, which is a big thing, right? Now that our screen refreshing is being controlled by the graphical user interface, if we don't update the screen, it's just going to continually show what was previously there. So that's also what I wanted to address. I thought that might not have been a problem because we're repainting to the board, but I just realized when we're repainting to the board, we're not actually fixing the board for the previous blocks. We're just leaving them there, just inactive. We're not changing the colors. Remember, the color is not tied to the activeness of the block itself. So we're gonna go to our clear line function, which should be right here. Check and clear full rows. You see, here we set active to false. Again, we didn't update the colors, right? So we want to update the color of the block to be black. And I believe we could just do color.black at this point. Is it called color? Okay, it's called color. And that way when we clear lines, it's gonna actually change their colors to black. So internally, they were the same, just yeah, so you can see now it clears the lines. It actually didn't clear the line the way I expected it to. What did it do? That's weird. Let me see. Yeah, okay, it didn't. Interesting. So yeah, it looks like it's not. Let me see. So we set the active of the number of rows down from where we were checking. And then we set the rows. I see. So we need to set. We need to change the colors of the dropped rows as well. The state of both of these is like detached from each other. So the color of this new row, the new color here, is going to be equal to the color from the old place it used to be at. So we need to include not only the color change when the block goes dead, but when the block is being moved as well. That's what was happening. It was kind of hard to tell with that first clear because I couldn't really... It didn't really make sense to me how it was doing that. Let's see if it will... Okay, now it looks correct to me. I don't know about you, but that looks like a proper display of what a line clear looks like now. So I think for the most part, everything is all set now. Now, for those that don't know, I'm a really bad Tetris player, so I'm not actually going to be able to do anything crazy in terms of like setting up like my field or anything. But I think that's the great thing about Tetris, though. It's a pretty like simple game, right? So a lot of people can enjoy it without having to know anything super technical about it. The only thing we have to add now is some of the game rules. So now that we have a functioning Tetris like engine, we can go ahead and start accomplishing some more of the detailed like game rules. So, for example, I know in Tetris most of the time you clear 10 lines, you go to the next level, right? We already add some details about increasing the speed when you clear 10 lines. So we can go ahead and incorporate that. We also know that when you reach the top of the screen, it's a game over. Right now, we just have an error when that happens, so the game just abruptly dies. But that's another thing we need to incorporate, like the ability to restart the game if you lose would be another thing to incorporate. But the core functionality is there, which is good. This isn't Tetris. What do you mean this isn't Tetris? What is this then? What would you call this? So let's do some game rules now. Let's keep track of the score somewhere. Not the score, the number of lines cleared. We're gonna store in an integer called lines cleared. So every time we clear a line, we're gonna go into where we just did the shift blocks down by number of deletion rows. This tells us how many blocks were cleared. So here we'll add in a lines cleared goes up by the number of deletion rows, number of rows deleted. That determines how many lines we cleared. We would like to display that somewhere on the screen. So back inside of our game canvas here, we will draw that number somewhere. Again, it's good to avoid using raw numbers because you want to be able to change things quickly. So up here we're going to define a lines cleared display X, and we'll include a Y as well. So let's display it at position. Let's see, if the board was 24 times 10, 240 pixels wide. Let's see. Divided by 2, 120. So let's display it at like 1x of 180. That sounds like a good position. At least the start of it. And then the display Y should be at whatever the window height is divided by 2. Or just try to display it there or something. So to draw text, let's first set the color to a color we want to actually use. So we'll use a white color to display it because we're drawing on a very dark display. And you just do g.drawText, I think. Draw a string, excuse me. And then you can specify a string along with the coordinates, which in this case will be lines cleared. Now, I will warn people that use this that the default drawstring is very, very like primitive. It doesn't do a whole lot. So this is actually what you can spend a lot of time like messing with in the future. You can go in and change how it looks with a lot more detail. But for something very simple, you can do something like this, and we're gonna have to convert that to a string because it's all by itself. Integer.toString. If you're drawing numbers just by themselves, they won't auto-convert to a string. So you can see there is a very tiny number over there. I actually wanted it on the right side, not the left side of the board. My bad. So I wanted to do window width divided by 2 plus 180. Now, obviously the size of it is a problem. For something that's going to be over here, we want it to be a much larger number than that. So to set a size, you need to specify a font. So we can actually specify the font directly in here. I think it's just called a font class, but we'll call it the display text. That's usually what I like to call it. And I believe the font constructor requires two values. It requires the name of the font and a size. I think you can just specify the name of the font without it. Let me see, string int float. We might want to look up the docs on this one because I don't remember exactly what the other value is supposed to be. So we'll look that up real quick. So when you're looking at docs, if you're looking for constructor, here you go, name, style, and size. Ah, okay. So it says the style constant. It can be plain, bold, or italic. I think we'll use the bold style. I assume it's a constant under the font class. Yeah, so we'll use bold. And then you specify a number. So the name of the font can be anything you want. It has to be a font installed on your system. And I believe you have to use what the like font family name. So Consolas is a good font I like to use. So we'll try Consolas and see if it recognizes that. Bonsolas, yes, totally. And now we have to actually use the font. So when you get a font object, I believe all you have to do is draw straight from it. So if I do display text dot, let's see. I think there's a... We might have to set the font. Set font. So we can set the font before drawing, which I think is what we want. And you can see here now there's a giant 0. So if I go around and actually do some lines, if I can actually place blocks. You'll see the number increments by 1 because I have cleared a line. So that's all good. So that went up by 3. So yeah, we can see that it clearly displays the number of lines now. Now what we want to do is add in some logic to increase the fall speed of the block as, well, increase the level as time goes on. So we're already storing what our current level is here. It's actually set to 0 because internally that's what value in the level delay array we're using. But we're going to visually display the number 1. So we're going to make 2 more coordinates for displaying the level. So we'll call this the level display. Now we're going to need to label these as well with actual words like what these represent. But we'll do that in a little bit here. We just want to get some numbers displaying so at least we can see those values in action. Now that we're using this instead of a decoded... So here, since it's referencing, it's going to be dependent on where line cleared display is, we're actually going to use that and just subtract like 64 from it. So that when I display this, it's going to be game.level plus 1 because we want to display, if internally we're storing level 0, there is no level 0, it's level 1, so we're going to display the word 1, or the number 1. 1. Like so. So now we have the number 1 being displayed right there. And now we have to make it so when we actually clear enough lines, we advance to the next level. We'll just make the level advance whenever we detect that a multiple of 10 has been reached. So every time lines are cleared, let's go here. Lines cleared plus equals deletion rows. If lines cleared divided by 10 is less than or is greater than level, then we're going to increment level by 1 if level is less than a certain value. So, and level is less than 20, then we're going... Wait, do we have 20 levels? Let me see. So we have 20 levels, but level should not be going past 19, because 19 is the 20th value, because it starts at level 0 internally. So when we reach level 19 internally, it's going to display level 20, which is the last level. Level will be equal to lines cleared divided by 10. That's all we have to really do. Once the level is above 19, we can't really increment it, and I think you'd have to be a pretty, like, darn good player, I think, to even get to that point, because I think it gets too fast. Like, I'm trying to imagine right now what that would look like if you were to just do such a, Now, you might notice, one issue I'm kind of having is that I can't, press it down while pressing left or right. I have to stop doing one to do the other, and that's kind of an issue with the whole holding down a key thing, is that you're not detecting like multiple keys being held down, and that's something we can fix pretty easily. What we would have to do is have an array storing how many wait, what? Is that a bug? Or was that the blue piece? I need to check that again. The next time I get a blue piece, I need to check the rotation on it, because I think it's bugged. I think it's only the blue piece, though. Everything else is good. Good. So it says we're on level 2 now. I don't think it gets much faster because it's only level 2. I think the amount of time it takes increments by a speed, it's like 3 frames, so it's not actually much. Okay, yeah, that is weird. I'm gonna have to look into that. So the blue piece is bugged a little, and that might have just been a mistake on me when I wasn't looking. Let's see. So here's the blue piece. Yeah, look at that. This shape and this shape are exactly the same. Whoops. So we need to fix that. It needs to look like this when it's rotated in this fashion. Okay. That looks better. Looks like it's rotated correctly now. Every other piece was good though. One thing I did notice as well was I couldn't rotate the T piece on the edge of the board. Neither can I rotate this piece on the edge of the board. And that's partly due to how we coded the rotation algorithm. It will try to rotate the piece as best as it can, but if it can't fit it, it just doesn't let you rotate it. However, on the edges of the board, I think it should be able to like detect an ability to... Like, I don't think our movement rotation algorithm really worked for that. So we're gonna have to check that. Rotate if space is free. Let's see if we can fix that a little to make it feel better. Because right now we're always checking one to the left and one to the right, and seeing if those points made it so we could rotate the piece. So what I want to try now is moving not only one, but maybe 2? Because sometimes we have to move 2 blocks, I think. It doesn't feel like it changes much, if at all. Like, it doesn't let me rotate this piece. But you can see here it kind of works, so... yeah, it doesn't seem like it can rotate even if I change this. That's interesting. But I assume the offset is being applied. because this point represents the offset along the x-axis. So what it should be trying to do is trying to see if the position it's looking at plus the offset is within the grid. So if it's offset by like 2 to the left or 2 to the right, it should be saying, no, you can't move there. But if it's free, it should let us go there. Because I know for a fact that when I try and rotate this, not this piece, these are bad examples, stop. When I try to rotate this piece, I know I can rotate this piece in such a way that it can still fit in that little area, so I feel like it should be able to handle that kind of rotation. I think I noticed a pattern. It works on the right side, but not the left side. So that's kind of interesting. Let's have a look at only the right side looks for if point.x plus offset.x is greater than or equal to GameGrid.length. X represents the... Right, X represents the 10 columns. So, that does sound correct to me. What I'm confused about, though, is why such an extreme offset doesn't work. Like, if I were to specify -2, -3, and -4, I feel like at some point it should say, okay, I can teleport over to those squares, because those are much, much further away. But clearly we're not seeing that happen, so I feel like it's not working. And so now I'm trying to figure out why not. Why isn't it working? It should be iterating through every single offset and trying for those points. So let's do some debugging and try to figure that out, because that's kind of annoying. I want to be able to rotate my pieces, and I made this code specifically to avoid that. So we're going to... First we're going to see if we can found an offset. Let's first see if it even finds an offset. Okay, you see it does say it found an offset. So why didn't it rotate the piece? If free offset is not equal to -1, rotate it. Okay. Okay, so the second statement doesn't get executed. So let's find out why this doesn't get executed. Free offset starts at -1, but once it gets set to something else... Wait a second. I'm dumb. Guess what this is? -1. How about we use a value that's never gonna be... Dang it. Okay, so this piece doesn't work because I believe it needs an offset of 2. So yeah, this piece kind of has an excuse. We're gonna have to fix that. But for every other piece... Okay, now it works. We can actually rotate pieces now. Except for this piece, and that's only because it needs a special offset. So the offset value will actually be determined by what type of piece we're looking at. So rotate if space is free also needs to know what type of piece it is. So we can do this in a couple ways. We can just check the current piece we're on directly, because this is the only place we're using this in. or we can pass down the piece directly. I think it's better to just check the piece directly at this point. So if get current shape is equal to, how do we know it's that piece though? Let's see. Ah, we stored them in values called, well, these variables aren't initialized here though. Ideally, we want to initialize these in a place where we can access them. So maybe out here, making them static would be good. We'll also have to make them public because we want to access them from outside here. Is equal to eyepiece. When comparing objects, we have to use the dot equals function. So frame is on, oh wait, this is like frame, not a shape. Dot shape, get the current rotation. Okay, so we're gonna check if the whatever piece's rotation we're currently at is equal to whatever the current shape is. And if it is, then we know for a fact that it's going to be an eyepiece, so the offset needs to be different. Offset needs to be equal to 0, -1, 1, -2, or 2. That way eyepieces get special treatment. So you can see now I'm able to... I can't rotate on this edge though, only the other edge. That might be... Let me see. It's either the... I think it's the equals check not going through. Is eyepiece. Yeah, maybe it's not detecting as an eyepiece. Wow, Tetris. Yeah, so this is the final day for this project. The last 2 days we spent building the logic. So today we're just building the graphical interface. And so we're just seeing like the fruits of our label kind of. So it does detect it is an eyepiece, just the offset isn't enough. Does it really need an offset of 3? I guess it does. So we're gonna give it a -3 offset here, because apparently it needs it. And that should allow us to rotate the piece on the edge now. Yep. So that looks good. In any case, yeah, this is a... We're just finalizing some things, but this is essentially as good as done for our intents and purposes. We built all the game logic yesterday, so we already knew like we had a functioning Tetris game. We just didn't have the graphical interface, so today we implement the graphical interface and we're pretty much all set at that point. No! Oh, great. Alright, so I think the key holding thing is starting to bug me, so let's talk about the fix for that. So the reason why the key holding, you can't hold multiple keys down right now, is because we're not actually storing what keys we're pressing. Right now we're just doing whatever the keyboard tells us. And if you've ever typed with the keyboard, which I'm sure everybody has in their lives, then you'll realize you can't like press a key and then press another key and then your previous key is still typing. Like that's just not how it works, right? So in order to overcome that, we need to store whenever a key is pressed down and then keep the held state for that key in memory until the player releases that key. And at that point we're like, okay, you're not holding that key anymore, so I can let it go. Because right now I have to manually position the piece before I can drop it down because I can't hold down and I can't move at the same time. And that's just a restriction of how keyboards work. So in order to fix that, you have to actually you have to actually keep track of the key held state. Okay, I do feel the piece is getting a little faster now, so the levels indeed do work. So let's work on the key holding aspect next. I need to stop playing this game. Stop. Sig, stop. Okay, anyway. So it's not really keyboard ghosting. That is a whole separate thing. But what is going on is we're using the, what do you call it? We're using the basic keyboard implementation right now to directly invoke which key we're pressing down. So instead, we're going to be making a hash map. A hash map is good because it can store keys holding what key we're pressing. This isn't supposed to be a pun, but kind of turned into one. So we'll be storing a key event, which is really just an integer, which is going to be the key, and then what state it's currently in, whether or not it's being held down or not, so we'll need a boolean there. And this is going to be a key map. So we'll initialize that. I think key events are just integers. Let me double check. I have a strong feeling that it's not an actual... Okay, yeah, they're integers. Key event is just an enum that holds integers. So we'll be switching to integer there. Okay. So now, instead of immediately doing this, we're actually going to do keymap.put. We have to specify game keymap.put, and we're going to be putting in the key code. So we're going to do e.keycode, and we're going to be making this out here. And so that's going to make things kind of easy for us because now we're going to be moving all the game logic of like pressing keys into the step event where we're going to handle keys. So we're just going to call this handle keys. And so we'll need a new function method for that. That'll all go in here, and we'll be refactoring that in a second here. It's not applicable for the arguments int. Well, yeah, you're right, actually. True. So this is when we press down a key, and then we have to set it to false when we release a key, like so. So that's how we handle a key mapping. Now we can just check inside the key mapping for each of these events. So we're going to say if keymap.get. Well, first we have to check if they contain the key, which is kind of annoying because we have to like, basically we have to have this structure where we do this. Or, well, and keymap.get key event.vk left. Then we do something, or we can have another one of these for the other key. But you can see this is going to get really like messy and tedious really fast. So we're going to turn this all into a function. So we're going to refactor all of this logic. Our key are keys held down. That's what we're gonna call it. Because we don't want all that mess. We just want to be able to specify 2 types of keys. Or any number of keys, really, and see if any of them are held down. That's really what the goal of this function is. So we're going to accept an array of integers. We'll call it keys. And then we'll look through each one. For int I is 0, I is less than keys.length, I plus plus. And inside of here, we'll do this logic, basically, what we just wrote here. So if keys I is contained inside the map, and that is true, then return true. If we get out here, we just return false. And that way, all we have to do is specify this instead of the giant glob I had earlier, and then we just move our logic into place. Now, we just have to copy paste this and change these real quick to be different keys. So again, we have the right key or the D key. We have the Z key or the comma key. Can't type. We have the X key or the period key. The S key or the down key. And then we just have to move all these. And we should be good to go. Our game should still work the same way. Well, actually, it's going to work a little better, because now I should be able to hold down. Oh, you can see it's actually a lot faster because we have no I have no delay in my key presses now. So I might want to add that because I don't want to be okay. So I forgot this is being handled in the step event. So this is being processed once every 60 frames. So we actually want some natural delay inside of our keyboard inputs because we can't do, I'm not going to do frame perfect inputs in order to press and stop pressing certain keys. For some keys, we want them to only change, like for example, rotating, right? We only want rotations to happen every time we press the key. We don't want it every time it's being held down, because otherwise you just get that spazzing this, where it's constantly rotating. We definitely don't want that. So yeah, we're gonna be making it so some of these are only happening when they're actually pressed. So this is for our keys held down. We can also just do some logic in here for pressing. So I'm gonna be moving rotations back into there. That's probably a good idea. So here we don't use these functions anymore, we use the other functions. If e.keycode, or getKeycode, is equal to this, or it's equal to that. So rotations are handled in here. And this should make it so only when I press the key down does it actually rotate. Yeah, so you can see now it's a lot more manageable for me. If I hold it down, it still lets me like toggle between the rotations, but it's more manageable now because at least it's not happening every frame. Now as for the movement, yeah, the movement is also needs to be controlled, but not in the same way. We need to add like a delay between every single what would you call this? Every single held down press, like input, because otherwise it's just going to be too much for the player. So then naturally we're gonna have to delay. Holding right, holding left needs to have some kind of delay. Doesn't have to be much, but some kind of delay. So when we first press down a key, we're gonna call this the key delay. So it's gonna be just some initial delay that is set. Key delay. So every time you press a key, well, one of these keys, I should say, move block left, move block right, or even down, it's going to trigger this key delay. So one easy way to actually do this is to make a list of keys you want to check, because I don't want to write out a giant if statement, at least if I can avoid it. Keys. I'm gonna do it this way. This is a little cleaner. Key event left, key event A. I'm gonna put them on separate lines so we can kind of see the separation by functionality. And finally, key event VKS and key event VK down. But yeah, I highly recommend tuning in every day if you can, if you want to learn more about programming in general. I started doing this every single day, so I'm gonna keep it up and try to produce some valuable like skills to learn. In theory, try to always be doing something interesting, varying it up. I think the next thing I'm gonna be doing is starting tomorrow is talking a little bit about Discord bots, because one of my friends wanted to know more about that. If there's anything you're interested in learning as well, you're more than welcome to throw some ideas out there, and I can add it into future possible programming sessions, because I would like to tackle a huge scope of things to get exposure to a lot of different like things. So we're gonna see if keys.contains whatever key code we're passing. So this is gonna check every single one and returns true if the list contains the specified element. So I think it's just gonna convert them to integers, and integer objects I believe are equal as long as they have the same value in it. That's just how they're implemented. So therefore, if keys.contains one of those keys, we're going to set up key delay, key delay to be equal to, I don't know what's a good delay. Let's say maybe like 20 frames, like 1/3 of a second, and then it starts dragging along. I don't know, that sounds like a good value. So here, if game.keyDelay is equal to 0, then do one of these and set key delay to, what's a good tick rate, like 6 times 10 executions per second. I think that's a good amount. Else game.keyDelay equal or goes down by 1. And this way, when we first hold down the button, it waits some amount of time, or at least in theory it should, but it's not detecting that's one of these keys, which is a problem. So why? It's entirely possible that the contains function does not do the right call. Returns true if and only if this list contains at least one element in E such that O is equal to null. Then check if E is equal to null, else O.equals. So we're entirely reliant on the equals function to check if it's equals or not. Well, unfortunately, the equals function is not giving what I thought it would. And that's partially because I think what happens is each integer object is considered its own thing. And that's more of a technicality with the Java language when it comes to handling objects versus primitives. It's a pretty complicated topic, and it's really annoying that they exist in the first place, but it's the way Java does things, so. Don't get me wrong, I absolutely love Java, but There are a few quirks in any language, regardless if you love it or hate it, that just you wish was not the case. It doesn't matter what language, you're always gonna find languages have their ups and downs like that. I'm surprised it still doesn't work. Okay. Oh, I see. So wait. I feel like it was let me go back. Let me do some debugging because apparently this is executing. Executing. Okay. So indeed, it is displaying that. Now the question is, why isn't this part working? We have handle keys being run in the step event, so every step if game.keyDelay is equal to 0, do one of these set key delay to 6. Otherwise, decrease key delay. Does key delay start at 0? I think it does. That might be the problem. We need to check if key delay is less than or equal to 0. Unfortunately, it's still not working. But I think I know what's happening. If we hold down the key, each time key delay is being set to 20. So this only happens the very first time we press the key if the key has not been pressed. So, if it had a false value, then set it to true. That is the logic we need to incorporate here. If game.keymap.contains key, we.get key code. And or it does not exist. Oh, we also have to check the value. Key game.keymap.get e.get key code. And we're gonna check if it's not true. And this contains that. Otherwise, if it doesn't contain that, then we execute this as well. So basically, we're gonna see if the key map has a value in it already, then check if it's set to false, means it's been released, then execute that code. So you can see now it's actually working the way I would expect a Tetris game to handle this kind of thing. So now we can only move a certain speed to the left or right at any one time, or drop down a certain speed. So that is quite interesting. Now what's also interesting is that regardless of which key I held, it will start holding down that key at a different rate, which is not quite what we want either. We really only want to change that for like the left and right keys, and only if we release. So the key delay should only happen on a global release of every key. So if there's another key that hasn't been released yet when we release it, then it shouldn't reset the timer. So we have to check every key in this list to see if all of them do not have a key pressed down. Because if none of these have a key pressed down, then when we first press a key again, it starts the key delay once again. So when we press the key the first time, yes, it's going to do a key delay of 0 and then key delay of 6 after. I think in order to simplify things, it's better to just make it so on a key press, you get the result, and then it just sets this delay in here, this kicker. I think emulating the initial press is a little too... It's a little too overkill, and I don't think it's necessary for a video game. Maybe if it was like a... So this is the fastest we can move. I feel like we should make it a little faster. Let's bring it down to like 4. Let's see how that feels. Yeah, that feels a lot better. I think this is a good speed to max out at. If you just like hold things down, in my opinion. Also, I feel like clockwise, and counterclockwise or backwards, but that could just be how I'm used to controls. So yeah, to me, I feel like clockwise and counterclockwise should be opposite. Could just be me, but it really doesn't matter. Like, you would be able to define how you would rather have your controls, but to me, that makes more sense. Oh god, I literally cannot. So this is, yeah, this is like the max drop speed you can go at, which is fine, I think. It's pretty good speed to be at. It feels a lot better now. I can drop while moving. So now the controls feel fluid, and that was the last thing I really wanted to accomplish here. Now I will say that at least on a basic level, the clone is done. Maybe we should add some text labels to say what those two numbers on the side mean. We haven't handled the losing condition either. Maybe we want to implement that real quick. I feel like that would be a good idea. Oh, we can also draw what the next piece would be, like somewhere on the side. I forgot about that as well. Next piece is always a nice thing to display, right? Oh, crud. My Tetris skills are being tested right now. Oh. Triple, quadruple. Saved. Saved by 4 bar pieces. 4 eye pieces, whatever you want to call those. Oh, I just suck. Okay. Okay, I think one problem I'm noticing, it's very subtle, but the key delay does reset with every like key press, right? Which could be annoying depending on what you're trying to do at that time. Because sometimes you want to, like, every time I change directions, the key delay should be reset. So the key delay should only happen if the key I'm pressing is the same key I pressed before. If I press a new key, the key delay should be 0. So that's one thing I noticed. Sometimes my inputs would drop, and that's because of that reason, because of this. So we're gonna make an override that says or what we're pressing now is different than what we pressed before. Because if we're holding down the same key, yeah, okay, that's fine. We can move that block. But if we press a new key, yeah, we need to do something else. So we're gonna add a new variable called last key. So every time we press a key, we're gonna set last key equal to that key. Last key equals get key code. And that way, in our logic, whenever we press a key, if game.lastKey is not equal to, oh wait. So now we have to move the key delay functionality into these because we need to check are keys held down and game.keyDelay is less than or equal to 0, or what we pressed now, or what we're pressing, which are those two keys, is not equal to that. Key event vk left. It's not equal to game.lastKey. and A is not equal to game.lastKey. So then we move this into here. Yeah, this logic makes sense to me. We have to make sure the last key is not equal to either of these. And if it isn't, that means we're still holding it down, so we can keep on executing what is inside of there. But if it is one of our new things, then we have to pause. I don't think it... Hold on. I didn't set the key delay for the other blocks. That's why it only left had the delay. Okay. Feels fine now. Oh god, wait. Hold on. Interesting. I think the solution is to have every key have its own key delay. Yeah, every key needs its own key delay. That's what is going on here. We can't share key delays because sometimes you need to press another key. So if we reset our structure to this, we can't just have one key delay anymore. Every key needs to keep track of what its key delay is, so that when you hold it down long enough, then it starts repeating. So let us now change this structure from being just a direct pressed and not pressed state to being something a little different. Key map and key times. We could make a class that actually says what that keeps track of those two. Like, so these two, the Boolean and the integer, can both be in one class. And I mean, we could totally do that. We just call it like a key, and we'd handle it in there. And then we could have one map that has the key information, like that. Inside we would store a Boolean containing pressed or not pressed, and then its current timer. When the key is created, it's just going to have an initial state of this dot pressed is false, and this dot timer is 0. That way your initial press will always be instant, and then every press after that will be dependent on the timer. Okay, so we're going to be using this structure now that we created. So first thing we have to change is, instead of putting the key code into our map, we're going to be putting in an object, or a key object. So if the key map already has this key inside of it, then we have to actually grab its current object. Otherwise, we have to put a brand new key code object in. Key. We have to provide, we have to provide when it was pressed, or whether it was pressed, which will be true. Oh, I guess we're gonna specify that here. Pressed. And sets timer to 0. This constructor is undefined. It needs to be public, that's why. Otherwise, grab whatever the current object is, which is going to be key k equals game. I guess we could specify in here though. We could say game.keymap.get e.get keycode dot update press to true. And update press is a function we can make inside of here. And we have to return our key, so we'll return this, but we'll set this dot pressed equal to pressed. This is a very like this is what we called like how you would produce like a factory, as they like to call it. A factory object always returns itself after updating a property, so that you can like chain multiple calls into the same object. It's called a factory because you're just passing this along a conveyor, as you will, of different like methods. So that's kind of where the name comes from. And so we're going to be putting we're going to update press, and since it returns itself, it's just going to return the same object back. And then we have to why isn't this working? It's not applicable for the arguments nothing. What do you mean not applicable for the arguments nothing? I guess I just it's the IDE being dumb. I'm like, what? So yeah, all this does is make it, this functionality remains the same. The new functionality we gain is now we can access this like timer value elsewhere. I believe there's an error down here. Oh yeah, key released. So if we press, we know there's gonna be a release. So game.keymap.get get key code dot update press to false. Then we go over here, and now we're gonna say our key is held down. We're gonna get the object dot pressed to determine whether or not it's held down or not. Now if it is held down, we need to do a delay function for it. So we're gonna make a constant variable that is like the default key delay. Default key delay equals 4. I think that's a good value to put it at. Update key delay. Okay, so our keys held down is also gonna be holding the timer variable. We don't return true unless the key delay for this is set up correctly. Keymap.get keys I dot timer is less than or equal to 0, then return true. Then you update key delay after that happens. And you can do it for either one. I guess it doesn't really matter. We haven't made the function yet, so we're gonna have to do that as well. But that should be the basics to having it so each key has its own delay, which is like our custom keyboard behavior. When you're making, when you're doing like technical details for implementing like game engines, this is usually the stuff you're dealing with. You're dealing with how to handle keyboard inputs, how to handle specific like edge cases, things like that. This should be an integer array of keys. And we'll kind of do the same thing as we did down here, but in update key delay, we'll make it so we set key delay equal to, let's see, We want to see if the key map contains the key. We don't need to check if it's pressed. We just have to set the timer. So again, we'll do a factory setup here. We'll do set timer to 4. No, not 4. Game.default key delay. That way we can easily change what the default is supposed to be. This.timer equals default key. Oh, let me change that to timer. Like so. Boom. And return this. We always want to return itself. That way it can be used in a factory setup here. So we can do keymap dot put. We don't even have to do keymap dot put, I don't believe. I believe it'll just reference itself. Maybe not. Keymap dot set. Or maybe it will. Maybe we're not decrementing it. Yeah, we're not decrementing it. Oops. So we actually can do that here. Else. Then we check for this. Set timer to whatever the timer is -1. I don't know what I was trying to type before. I also noticed that you can't adjust the position when it's above the board. Which isn't like a super big deal, but what it does mean for us is that occasionally you end up in this weird state where the block has not spawned like into the grid down below, so you can't move it until it's gone far enough down. So that's another thing too. Even though the block is above the board, you should still be able to move it side to side if it's not above the board. So we need to add another exception for that as well. And that's going to be in our move block function here. So is occupied should not return true if y is less than 0. What it should do instead is just not render those blocks in the grid. Or if it does render those blocks, it just doesn't update the grid in that sense. Let me see. Because it doesn't exist, so it can't do the check, right? So if it's occupied or p dot y is plus, well, there's no offset, I guess. P dot y is less than 0. No, greater than or equal to game grid dot grid 0 dot length. This will make it so that even if the block is above the grid, we can still move it left or right. So let me get a block that actually starts above the grid. Come on, give me one that starts above the grid. Okay, it still didn't work though. Is free is false. Oh, I see. This is if it is occupied. So we want to say if it's not occupied. Let's say and it's less than grid.length. If it's in the grid. Otherwise we ignore this check. Alright, let me get a block that's above the grid again. Okay, it still doesn't work. So, what else can we do about this? Because the thing is, when you start, the block could be like above the grid. And if it is, right now we can't move it. Because of this check. But we should be able to move it, because let me see if the translate just moves a point. So that's when it's clear. So we want to check if the point at that position is less than, well, the length of the grid, which is 20. So if it's within the board bounds and it's occupied, isFree can be set to false. If so, I want to at least output what that would be. Okay, so we see that it produces the value of 19. Which does explain some things, right? So 19 is less than the length of the grid. So if we add in a -1 there, now we can move it when it's above the grid, like so. And that's exactly what we want. And that was kind of a big deal because it's still not working. At least I don't think it's working. It works for this piece. Let me try a different piece. Let me see. $18. That's kind of weird. I feel like that this check is not supposed to be required. Like, what that's telling me is that for some reason it considers the top square 18. I feel like it actually is not 18. Saying the blocks at position 18 are occupied. But that doesn't really make sense, because let me see what the y-x is. This is saying that position is occupied. It's like the only thing that's bugging me. If the piece is too high up, it just doesn't let you actually move it. Which is weird, because I think if it has the ability to be moved, then you can check if it's occupied. Let me see. What does our function do exactly? Checkpoints based on an offset. The offset is going to be 0 in these instances. See if y is greater than or equal to 20, or x is greater than or equal to 20, or greater than or equal to 10, my bad. Or the y offset is less than 0, or that is less than 0. Or if none of those things are true, then seeing if that grid space dot active is true. Would those spaces be active? Ever? I don't think they would be. I don't think so. I don't think any of these like logic points would apply to this. Okay, this is where things get interesting. For each piece, we do set a new point equal to -y. So the piece itself, the shape itself, has points that are located going downward from its initial position. And that kind of makes sense. It's like blocks that are falling go towards 0. Blocks near the top are going towards 20. So I wonder... Now the block is actually above the field, so it does do an array index out of bounds exception. Which means the block isn't drawn within the game grid. I think that's the issue. And we're drawing that here. So I think that is where the error occurs, right? Because we're at snap piece that collided. Oh, I see I have this as well. I forgot about this. If the point is outside of our grid, we lose. But we're not supposed to snap to that, though. That's one thing we're not supposed to do. So it does become active. I didn't even think about that. So there were just like blocks up there that were considered active. At least in theory, I think that's what was happening, but I still can't move the blocks, so I'm not sure if that's actually accurate. I guess we would have to go into more detail about why this part is turning into a... why this check is causing this to happen. Because, I mean, I can output these, but it's not going to give us too much info. It's just going to tell us, okay. So I saw here we had a -1 there, which didn't get a pass. Which makes sense, but that is also why we're having issues. I'm not checking the bottom, I'm checking the top. That's why. I forgot, it's inverted. If p.y is greater than 0, I guess greater than or equal to 0, that's the entire reason. Let's see. What were the movements just now? Let me see. Okay, maybe it's not the entire picture, but it might help us. (10/18) came out as 7/18 here. (10/18), and we said that was occupied. Which is weird. Because that's not the top. Or that, I guess that is the top, but... the bottom? That was the bottom, excuse me. I think. Am I understanding this right? No. Hmm. Maybe we just shouldn't render pieces way up there? I'm trying to think if that's okay or not. Like, where should the blocks start in theory, right? Another idea we could try is having the grid extend a little further than that, but only rendering up to 20. Okay. And see, that works. Because that now there's actually a place for the data to read that block info from. So that indeed does work. I think to explain what was happening before, we have to realize that there's no data up there for the blocks to fit themselves into, so really, the game just goes, where do I put this block? I can't draw it. It's out of bounds. So maybe if I added checks to check if it was out of bounds, that would also work. But this solution I think is simpler, because now we just have to check beyond the bounds to say, okay, there are blocks up here, that means we lose the game. We haven't added the lose condition yet, so I think to finish this off, we're going to add a lose condition and a way to restart the game. And then we'll be all set. And some labels, and then we'll be good. Let's remove a bunch of the system out print line stuff now that we've been debugging with for the past few minutes. Okay. So finish this off by adding our lose condition. Okay, so lose condition goes, every time we snap a piece, we're gonna see if, let me see, where are we? Okay. So if point.y is greater than or equal to, I want to say 21 is the max. If we get past 21, then we definitely lose, that's for sure. And if game state is equal to lose, we can actually like fade out the screen or something, and we no longer run the game. So inside of our step, where's our step? Okay. If state is not equal to game state dot lose, then we do all this. We still draw the board, but we don't do anything else if we lose. And inside of draw board, or not draw board, inside of game canvas, if we lose, then we're gonna make all the colors turn like gray or something. I think that would be cool. So if game state dot or game dot state is equal to game state dot lose, so we're using a ternary operator here, because those are always fun. Then we're gonna draw, we're going to use Java AWT color gray, light gray, we're gonna make all the pieces light gray essentially. Otherwise we'll use the normal color. We'll apply this to all of our set colors for all the blocks. And finally, let's try top out real quick, make sure that's working now. Top out as fast as possible. Okay, apparently we can't top out, nice. I must have put, I think I put 21, maybe I should have put 20. When the blocks are above 20, that's when it should fail. But I might put 21 because I thought maybe it was supposed to be one higher. Let's try that one more time. There we go. Just makes all the blocks gray. I want the inactive ones to, let me see. And dot active. I only want the active ones to turn light gray. So that way all the blocks you place down would be gray colored. Yeah, like that. That's a lose. Okay. So upon losing, we can display some text like hit R to restart or something. I think I have a util function for this. Draw center text. Perfect. I made this function a long time ago. It's in my draw utils. And the reason I made it was because I was tired of typing that every time. So yeah. Typing how to center text. It's basically just math to take the boundary of the text and then move it over naturally. So now we can get the window width and window height. Divide by 2. Window height divide by 2. For our color, color, white. This needs to be capital C, white. Text is press R to restart. So when we lose now, it should display that text for us. And then after that, I just want to add the labels for the level and the line count, and we'll be good to go. It looks like it doesn't like that. My robot cannot be... What? Is that what I'm using draw utils from? No. What happened? Oh. Why? I wonder what inclined me to use that instead. Interesting. I think it was something program specific. These utils come from my other programs, so naturally some stuff is gonna be... What the heck? It's still doing that. Oh, because it relies on text utils, which gets it from this, where I don't want to use that, actually. So every font comes with its own font metrics class, which I think is where this is coming from. So you would have to naturally get the string bounds and then do all that fancy stuff. However, I think this needs to be a panel. So if we really want to make this correct, we would specify a J panel here, panel, and then change this to be panel. So a lot of this is from like my old code, and so you can see there's a lot of like really some bad things, which I shouldn't have done. If I wanted to make this modular, I would have included the J panel naturally in these classes so that it can actually use those things. So I'm gonna have to make that change to pretty much all of this if I want to use that function inside of here. And there's one more down here as well. Specify the panel, and then we can actually use draw center text. So this is me fixing my old code. Nice. Always a fun time. We don't need this import anymore, and we don't need that import anymore. I also don't need like the rest of the stuff in there, so let's see. Now we have to fix draw center text in here to include a panel, and the panel will be this, so easy enough, right? Since today's the final day of this Tetris thing, naturally I'm working on it a bit more. Shuffle next piece. That looked a little weird, like it almost didn't want to fail, at least as far as I can tell. Either way, press R to restart. So we have to actually make it so we press R, we restart. So let's do that. E.get key code is equal to key event vkr. And call this game state is equal to game state dot lose. Then we will reset the state. So what we'll do is we'll set state equal to game state dot playing, and before we set to playing, we need to reset the board. So the easiest way to reset the board is, let's see. We have some functions to like initialize things at the beginning of the game, so we'll just run those again, but in here. Let's see. I feel like it's just done when we call a new player. Yeah, we select a random tetramino and we position ourselves. So we just have to reset the board and create a new player. So it's kind of interesting because if we set up a new player, it totally changes the current player instance. So we set up a new player, and then we define. Can we just define a new grid? We can. That resets the grid. So we literally just define a new player and a new grid. Game.gameGrid equals new grid. That's kind of cool how that works out, huh? So if I press R now, it won't do anything, but when I finish this, it'll let me restart. Boom. Now we're back at the beginning. I wonder if the level, I think the level and the level has to be reset too. Game.level has to be reset to 0, and game.lines cleared has to be reset to 0. Just some initial like state cleanup things. I think that's all. That's it. Everything else can remain the same. Outside of that, so that's resetting the game. Let's add in text. So here we got lines cleared, display. We're actually going to display the word lines, and then below that we'll display the number. So we'll display this at like +10. No. What's the size of our font? Like 24? Okay, so +24. We'll display the amount of lines. Yeah, like that. And then we'll do the same thing, but for level. Level. Like that. And then finally, we just need to display our next piece. So we can draw the next piece somewhere on the screen. This is how we get any piece, or not any piece. This is how we get our player blocks. So we're gonna, instead of getting current shape, get next shape. Apparently, next shape doesn't exist, so we need to make it. I think we didn't realize that sometimes we're gonna get the next piece. So return next piece, I guess. What is this? This is a frame, so we're gonna get just the unrotated version is what we're gonna get there. So when we get next shape, we'll get these points. Next points. And then for each of those points, we will render them somewhere. So we're gonna make a small box to display the next piece in. Call this next piece display. And I will make it relative to where the level display is. Level display Y minus 64. And then we'll make a rectangle. Let's make the rectangle a black color. At position next piece display X. Next piece display Y. We'll make the width and height 32. We'll make it raised. And then inside of here, we'll do set color equal to the pieces P get next shape color dot get color, and then we will draw those pieces using kind of the same block drawing format we've been using, except we have to draw it at position next piece display X plus 4, next piece display Y plus 4. That centers it within the box because it's 24 large and we have a 32 by 32 box, so add 4 to it, you put it 4 pixels off, it's 4 pixels off on the other side as well, and finally do p.x and p.y. Oh god. Whoops. Needs to be this plus next piece display X plus 4. I put the size as the position. That's funny. The size is just block size. Okay. Oh, I just realized it needs to be like way larger than 32 by 32. It needs to be like whatever 4 times 24 is plus 8. 104. Okay, so 104 by 104, which means I'm gonna make the display be like minus 128 or something. And finally, let's see. Point.x multiplied by, what do you call it? Block size. Wait, is that right? Yeah, that should be right. I think. Oh, never mind. Hold on. So right now the position of these is based on where the block is in relation to that. So really we just have to iterate through our shape and get all the blocks and then get all the pieces inside of there. So we're gonna kind of have to make our own function for that because the shape is gonna be determined by that as well. So yeah, we're gonna have to make our own function for that. Because this is relative to the player, not relative to... Actually, it is relative to itself. It's just... It gets translated by position.x and position.y, which is the position of the player. So we need to get relative blocks in grid, which doesn't have this line here, which is kind of annoying because everything else is the same. So really what we should be doing is supplying the position up here, which would make a lot more sense, by supplying like an offset. So I could put point offset here. Since we're only commenting out one line, there's no point in making a whole new function just for that. That would be very messy and very inconsistent if I want to change something. So offset.y. And then we just update all the places where that's called, which is probably in a couple places. So one here, where we supply the player position. For all the current uses of it, we just supply the player position. Except for that one. And then in here, same deal. Supply the position of the player. Yeah, this is what you have to do. This is what you have to be careful of when you're trying to create new functionality. It's like, if you're going to be reusing functionality that already exists with one minor twist, why not just refactor it so it can be used in many places, right? That would make your code a lot cleaner, as you don't need two of the same function, essentially, with that minor twist to it. You really want to try to avoid that whenever possible. I try to avoid it whenever possible because it makes no sense to use it otherwise. Now this time, our point is going to be, or our offset is going to be 0, 0. That way we just get the exact position where the block needs to be. Now I just need to render it properly. At least I think I'm rendering it properly. Let me see. Oh, okay, so yeah, now we're gonna get this p.x that we multiply by block size. I think. There we go. Now we just have to move the shape to where we kind of need it to be. What is this exception? That's interesting. So shape, you need to move to plus, what was it? 104, I think it was. Well, it's not 104, it needs to be like centered. So 52 plus, I think it's top centered though. Oh no, plus 52 as well. Something like that. Anyways, that shows the next piece. But it's not centered, like I said. I was kind of hoping it would be, so I might need to change that. Oh, I'm bad. I'm bad. Nice. Good one, Sig. Alright, we're going too fast. Fast is not good. Oh my gosh. Rip. Oh no. Oh, I thought this piece was facing the other way. Wonderful. Nice. We're not game overing. I think the piece has to start a block higher for the horizontal versions to line up. I need to display the word next above that box, by the way. Either next or like close to that box. Probably after it actually, so that's on top of it. Next. Yeah, that works. Yeah, I'm okay with that. So there you go, folks. Basic Tetris clone. I think Tetris is a good like starting game to try and build because it's got some very simple concepts that could be implemented with a grid-like structure. And I think if you're trying to make a game early on, making one with a grid is very helpful because grids are like the structure that a programming language works off of. Programming languages have these things called arrays, which are very powerful structures, and well, a grid-based game can entirely be built off of those kinds of structures using arrays. So that's exactly what we did for this game. Behind the scenes, everything's just stored in a giant array that is then being rendered. And that is the gist of making this Tetris clone. I know I went overboard today, but today was polish, so if you've ever tried making something and you got to the polish phase, not only should you be proud of yourself, but also it's kind of annoying because there's a lot of like technical details that you have to try to fix. And like I said, if you're working with the user interface, usually it has to do with stuff like how you handle key presses, minor details like I want it to behave this way and not that way, etc., etc. Like I noticed earlier that I needed to spawn the pieces one higher, and I forgot to do that. So every time we snap a piece, let me go to that real quick. And the nice thing about naming all of our functions what they are is we know exactly what they do, right? So that makes things easy for us. Shuffle next piece. There it is. You can figure out where you need to go next. So visually it doesn't look much difference. I made it so the pieces started a block higher, which is fine. It means that when pieces land, you can detect a game over even if the pieces are sideways, because now they actually spawn high enough to cause a game over, like that. Perfect. So I'm very happy with this turnout. It's been structured. It took about, I would say, 8 hours total to build this thing. We spent 1.5 hours the first day, 1 hour and 45 minutes the second day, and then 2.5 hours today. Okay, that doesn't add up. It's like 6 hours or something. But I think we covered pretty much all the basics. So in the future, would I recommend Java Swing for building games? Maybe. If it's nothing too complicated. Obviously, if you're going to end up having to build something more complex, you probably need a, like... You'll need to spend a lot more time fleshing out a game engine. And if you're looking for a game engine, you could probably search some online. I personally use, like, JMonkey Engine if I'm going to do something with Java involving, like, very complex games. But you could totally build your own game engine, too, which I highly recommend doing. I've built a couple game engines at this point for my own personal use, and it's very good practice for you because you learn how to do all these functions that you end up just taking for granted when you're building game engines in the first place. But you can see we can get pretty quick functionality with just Java Swing. It's actually laid out very easily, and if you want to learn more about Java Swing, you can find plenty of good documentation online. The official Java Swing documentation is very helpful. So I recommend every time I need to Google something related to Java Swing, I just go straight to their site because they make it pretty clean cut and easy to work with. So I recommend doing that first. If you have any questions about Java Swing, you're more than welcome to ask me as well. Hope you all enjoyed today's programming. It's been fun. It was fun developing this. I don't think there's anything else really to develop other than just playing it and enjoying it, so hope you all enjoyed. Thanks for watching.